So Wednesday, again, your test will cover all of Chapter 11 and Chapter 12. Of course, all of 11 and all of 12 that we will cover. Chapter 11, we did 11:1 through 11:4, and then Chapter 12, we did 12:1 through 12:3. So that's 7 sections. But of course, you know the Chapter 12 stuff, the stuff that we're doing on now, is review from Math 112. So that shouldn't be that big of a deal. So really focus on the Chapter 11 stuff, and study. Any questions? Yes?
The boss blocks in this test we had, 2 times we do the boss. Is that at just our basic boss blocks, or that add this?
Wherever you want it. It doesn't matter. That's not going to be your drop grade, so it's whichever way.
Okay, I know that we're going like a general model. So
It can. It doesn't matter. I think actually, in fact, what I may have done, for those of you who stapled that bonus onto your test, I did put it in my grade. But for those who did not staple it onto your test, it's just out there floating. So it's one and the same. This test was not the drop grade for anybody, so it didn't really matter. Any other questions? Okay. So, what we did last time is we started on the parabolas, talking about the conics, and there's 3 conics that you need to know. You need to know the parabola, the ellipse, and the hyperbola. And again, this test is going to be a little bit different from what you guys have looked at in the past, because there is going to be some matching on it, there's going to be some true-false on it, and there will be, of course, the open-ended like you're used to seeing. Okay? And one of the questions may be, like from Chapter 11, I may ask you, is this harmonic, geometric, or telescopic, the series, just looking at the series, and you can match. I may ask you a true-false question like, telescopic series always diverges. And you tell me whether or not that's true or false. Okay? Something like this, I may throw an equation on there and say, and just ask you to match the parabolas with the parabolas and the hyperbolas with the hyperbolas and the ellipse with the ellipse. Okay? So, this test will be a little bit different than what you're used to, just to kind of give you a heads up. When we left on Wednesday, I know you guys were exhausted, but we did talk about parabolas. So, in talking about the parabolas, on the test, probably what I'm going to say is I'm probably going to ask you to graph and discuss. I'll probably actually say identify, graph, and discuss the conic. Okay? Because that's how it's going to look on your final exam. Okay? So I will ask you to identify the conic, graph it, and discuss it. Now, let's say that you identify this as a parabola. How do you know that you're looking at a parabola? One squared term. Only one squared term. So we can identify this as a parabola. And when it says discuss, I want to know everything that's on your formulas page. The equation is given to you, so you identify it as a parabola. The equation is obviously there for these. So I want to know the vertex, I want to know the focus, I want to know the directrix, and the length of the primary focal point. Okay? So if it's on your formulas page, discuss it. Fair enough? All right. So let's go the other way. I may ask you to find the equation. If I discuss the parabola, I may ask you to actually find the equation. Okay? Now, there are a couple of different ways that you can do this. And I've told you guys before that I am an extreme visual learner, so I have to see a graph in order to be able to grasp it. Some people can just look at formulas and be able to do it. I can do that, but I'm picturing it in my brain. So I figure if I'm picturing it in my brain, I may as well put it on the slide. So let's look at this one, for example. This says find the equation of a parabola with a focus at 0, -4, and a directrix y equals 4. Now, there is one very, very, very important variable that you need to know in order to do this, and that variable is p. And if you'll look on your formulas page, down there at the picture of the parabola, you'll see the P and it's kind of out of place. So if you will, on your formulas page, just make a note that the distance from the vertex to the directrix is P, and also from the vertex to the focus is P. Okay? So however you can put that on that picture, that's what I need you to know. The distance from the vertex of the directrix, from the vertex to the directrix is P, and the distance from the vertex to the focus is P. They're the exact same distance. In other words, your vertex is right smack dab in between your focus and your directrix. And that distance is P. Okay? And in order to write an equation for a parabola, you've got to know what P is going to be. Okay. So this is what I do know. I do know that the focus is 0, -4. And I also know that the directrix is y is equal to 4. Well, if I graph that, I know that my focus is going to be here. And I know that my directrix is going to be here. So just from that information, what can you tell me about the direction of this parabola? It's going to go down. This one is going to go down. So off of that, you already know which formula you need to look at. This is where we're trying to get. I'm asking you to find the equation of the parabola. So on my formulas page, I need to know what H is, of course. I need to know what P is, and I need to know what K is. The X and the Y, you don't need. Leave it alone. That's part of your algebra. Just leave it be. Okay? Now, what do you know about HK? What is HK? It's your vertex. Your vertex is HK. And what did I just tell you about the vertex? It's halfway between your focus and your directrix. So if there's 8 units, right? If there's 8 units from your focus to your directrix, half it, and there's your vertex. So my vertex in this case is going to be 0, 0. So now I know HK. I also now know what P is. What is it? What is P? 4. P is the distance from your vertex to your focus or your vertex to your directrix. It's completely and totally your choice. So now, let's plug into our equation and see if we can come up with a workable equation. So what we're going to have is x minus 0 quantity squared is equal to 4 times P, which is 4, times y minus K. Well, the zeros don't really matter, so you get x squared is equal to 16. Wow. Now, there's one problem with this. Tell me what it is. What does that 16 tell me? What does 4P tell me? Look on your page. It does tell, yes, it does tell me the length of the primary focal chord, but look to the left of your formulas where it says parabolas open up or parabolas opens down, parabolas open right, parabolas open left. What does that tell you? Which direction does this parabola go? Which way does this parabola go? If this is your focus, the focus is always on the inside of your parabola. So this thing's going down. Your directrix is always behind your parabola. Your focus is always on the inside, so this thing is going down. So what does that tell you about the 16? It should be what? Negative. And there's your equation. So you have x squared is equal to negative 16y. That is your equation that you're looking for. Now, do you have to do it this way? No, absolutely not. If you want to use the formulas page verbatim, You can do that. And in order to do that, what you would have to do is, if you can compare your focus and your directrix, okay? If we know that the focus is 0, -4, and the directrix is y = 4, we, just by graphing that or getting a mental picture of it, we know that this thing goes down, okay? So we know that P has to be negative. In particular, P is going to be a -4, realistically, because it goes down. It tells us that on our formula page. If P is less than 0, it goes down. So it has to be -4. Now, all you have to do is go down through there, because we need to know what the vertex is going to be. So if you need to know what the vertex is going to be, all you have to do is look at the formula for your vertex. Or the formula for your focus, I guess you could say. So the formula for your focus is H, K plus P. Well, H is H. It's not going to change. H is 0 irregardless. And then K plus P is going to be K plus P has to be equal to -4. Well, if you add 4 to both sides, you're going to get 0. So either the algebra or the graph. It's completely and totally up to you. However you want to do it. Let's try another one. Let's look at this one. It says, find the equation of the parabola with the vertex is -2, 3, and the directrix is y is equal to 5. Let's figure out the variables that we know, okay? Vertex, which variables is that? H and K. There's H and K. And then your directrix is y equals 5. Well, if you have a line of y equals 5, is that horizontal or vertical? Y equals 5 is going to be horizontal. It's a horizontal line going through the y-axis at 5. Okay? So again, if you want to draw it, you can. You have a vertex at -2, 3. And then you have a directrix at 5. Now this is your vertex. What's missing? The focus. Do we need it? No. What do we need? You need up and down, and you need to know P. Okay, do you know what P is going to be? P is going to be 2, but this thing obviously opens down, so really P is going to be -2. Do you see how I did that? And even from this information, we don't need it, but from this information I could find the focus, couldn't I? It's going to be 2 units away. So this is what this thing does. Okay? But I'm looking for an equation. So really and truly all I need to know is P. Now, let's see if we can figure this out algebraically. The formula that I need, this thing is going down, so the formula that I need is going to be x minus h quantity squared is equal to 4p times y minus k quantity squared. And really I cheated. We don't even have to need algebra. Let's just do this. So we're going to have x minus a -2, which is going to be +2. And that goes hand in hand with what we said earlier. 4 times -2 is going to be -8. And then we're going to have y minus k, which is going to be 3. And there you have it. Again, if you want to use algebra, though, you can use algebra to find P. I don't, but you can if you want to. Questions? All right. Let's try this one. It says find the equation of the parabola when you have a vertex of 1, -2 and a focus of 1, 0. Before I write anything down, this is what I want you to do, okay? If you don't like the way that I'm doing this, I'm going to show you this way before I write anything down, because otherwise I'll get ahead of myself. To me, this is the harder way, but some people prefer this. What I want you to do is I want you to look on your formulas page, and I want you to compare your 2 sets of equations, the top ones and the bottom ones. And I want you to notice it's given the vertex and the focus. Which number did not change between the vertex and the focus? 1, right? The first one. look at your formulas, your two sets of formulas, and look and see which set of formula did the x coordinate not change, the top set or the bottom set? The bottom set. So again, we know that this one's going to go up or down, okay? So since this is the bottom set, we already know that this is HK, and the only thing left to know is P. Well, we know what the focus is. And the only thing that uses P is this right here. This is K plus P is equal to 0. Well, we know K. K is -2. So P is going to be 2. So algebraically, you can do this. But if you don't want to do it algebraically and you want to do it off the graph, which is what I prefer, we're going to do 1, -2. So there's your vertex. Your focus is 1, 0. So here's the focus. So I already know that it's going up. I know that the distance from the vertex to the focus is 2, which is P, which we already know that because we did the algebra. And if I needed to, I don't need to, but if I needed to, I could even draw the directrix 2 down. So we know that this thing's going up. All right, let's write the equation. So we're going to have x minus h, quantity squared, is equal to 4p times y minus k. So we're going to have x minus h, which is going to be minus 1, is equal to 4 times p, which is 2, so that's going to be 8 times y minus k. Y minus a -2 is going to give me a plus 2. So it's opposite of what you see. Easy enough? Alright, so let's talk about an ellipse. Do we need to review the vertex, or the parabola rather? Are you good with the parabolas? If you have any questions, just let me know. Okay, so for an ellipse, you need to be on the back side of your formulas page. You need to be on the back side of your formulas page, and that's where you can find the ellipse. Again, notice you have two different sets of formulas. You have a longer than tall, and you also have a taller than long. The only difference is this. How do I know if I'm working off the top set or the bottom set? Because it's just like every single one of your formulas pages in this class. If you don't know what you're looking for and how to use it, that formula page is no good to you. Okay? So I'm going to tell you how to figure out which set of formulas. First, it's got to be in the form that you see. You got to have two fractions, a plus sign in between, set equal to 1. Until you have that, you're no good. Okay? Two fractions, plus sign in between, set equal to 1. You've got to have that first. Once you have that, what you're going to do is you're going to look at the bottom set of numbers. Okay? You're going to look at the two denominators. One of them, the one that goes, and remember I told you this last week, X, H, and A always go together. Always. Y, K, and B always go together. Okay? So, if you know that, this is what you have to concentrate on. If, and it's out there to the right for you, where A squared is greater than B squared, if A squared is greater than B squared, then you have a longer than tall. If B squared is greater than A squared, you have a taller than long. And that's where you need to focus your attention in order to know which set of formulas you're going to use. Okay? So, let's look at this. Okay. Is this in the form that we need? Yeah, because you have two fractions. Plus signs in between. Preferably to lessen confusion, you want your x groupings to be first, okay? And it is set equal to 1. So, this is what I always do. When I work out the problems, this is what I always do. I always compare. So I know that A squared is bigger than B squared. And so I know where to go on my formula. I know that this one should be longer than tall. I know that I should be working off of the first set of formulas, because A squared is bigger than B squared. Now, if you know which set of formulas you're working off of, all you have to do is start at the top and work your way down. Okay? So here's your formula, and I gave you a huge hint as to how to tell where the center of the vertex is. What's missing if you compare this formula to the formula that's on your page? What's missing? An H and a K. And I know it's missing because there's no parentheses. Listen to this, okay? Here's the big hint one more time. No parentheses means 0. Okay? So since I don't have any parentheses, my H and my K, my center, is 0, 0. So you can check off the first one. You're done. The center, HK, is 0, 0, and I know that because there's no parentheses. Now, let's work on the vertices. If I'm on my test, I'm working on my test, and I see this, and I see the vertices, and I look at the formula, and I see an H, plus or minus, and I see an A, and I see a K. Well, I know what H and K are. What is A? 5. A is 5. How do I know that? Compare the problem given to the formula that's on your page. This is A squared. So if A squared is 25, then A is going to be 5. What is B? B is going to be 4. Okay? So now I'm ready to use my formula. For the vertices, it says H plus or minus A. Well, since H is 0, I'm just going to do this. Plus or minus 5. And then K is as it is. Okay? Now what I need you to understand is this is 2 separate points. Do you get that? This is 5, 0 and negative 5, 0. It's 2 separate points. I'm just lumping them together. Okay, let's go next. Because remember on the test, it's going to say identify, discuss, and graph. We identified it. It's an ellipse. Let's go back to that. How do we know that this is an ellipse? The plus sign. Because when we get to the hyperbolas, there's going to be a minus sign. The only difference between the ellipse and the hyperbola is one has a plus and one has a minus. Okay? So the plus sign tells me that it's an ellipse. So I identified it. Now I'm discussing it. Okay? So to discuss it, remember I told you, just go on your formulas page and go just straight down the line. So you have your center, you have your vertices. Now let's go with the minor axis. The minor axis says to keep H as is, just leave it alone. And then to K, add and subtract B. Well, B is 4, so we're going to do plus or minus 4. And again, that's going to be 2 points. The next thing I need to know is the foci. Foci is plural for focus. Well, what do you notice with the foci? There's another variable there. It's called C. Well, C is nowhere in my formula, but if you look one more step down, you can understand how to find C. Okay? To find C, you're going to do C squared. In this case, it's going to be A squared minus B squared. If you get a negative number here, you got them backwards. Just turn them around. So C squared is going to be 25 minus 16. So C is going to be what? 25 minus 16 is going to be what? 9, and square root of 9 is going to be 3. So the foci is 0 plus or minus 3. So we'll just put plus or minus 3. And then K is 0. So that's just going straight down the formulas page. Okay? So I identified it. How do I identify that this is an ellipse? The plus sign in between your fractions. Okay? I discussed it, and now I'm going to graph it. All right, so to graph it, the center is 0, 0. The vertices are going to be 5, 0, and negative 5, 0. The minor axis is going to be 0, 4, and 0, negative 4. And then the foci are really irrelevant as far as the graph is concerned. And there you have it. Okay, identify, discuss, and graph. And as long as it's in this form, it's easy to identify. But If it's in this form, not so much. Now, how do I know this is not a parabola? Because you see two square terms. I know that this is not a parabola because of two squared terms. X is squared and y is squared. All right, so we need it in the form that we need, and we've got to get started. You got to get it set equal to 1. Okay, so to get it set equal to 1, we're going to do what? Divide everything by 8. So if we divide everything by 8, what's going to happen is we're going to get x squared over 16. Just do 1/2 divided by 8. Plus y squared over 4 is equal to 1. Now it's in the form that we need. And this is what I want you to do. I want you to discuss. What can we discuss already? What is it? Good. How do you know? No parentheses. Your center is 0, 0 because there are no parentheses. Very good. What is A? What is B? And which set of formulas are we working off of? The first one, because A squared is bigger than B squared. Okay? A squared is bigger than B squared. All right, so the vertices, what'd you come up with? Plus or minus 4 and 0, is that right? Working off that first set of formulas. For the minor axis, what'd you come up with? Very good, 0 plus or minus 2, good job. All right, so now we need the focus. In order to do that, we have to figure out what C is. So C squared is equal to 16 minus 4. So C is going to be equal to the square root of what, 12? What is that in a decimal form? Yeah, but what is 2 radical 3? 3.5? Is that what I came up with? Okay, so your foci is going to be plus or minus 3.50. So there's your discussion. Now let's graph it. Center is going to be 0, 0. Your vertices are going to be 4, 0, and negative 4, 0. Your minor axis is going to be 2 up and 2 down. And the focus don't really matter. So there you have it. How'd we do? Extreme review. Okay. Alright. So this one's going to be a little harder simply because we're going to be off of the center. I know that I'm off the center because I have linear terms. Can you tell me what the linear terms are in this problem? 2x and negative 20y. So another big hint, if it's written out like this and you have linear terms, you're not going to be on the center anymore. Okay, it's going to be moved. So here are your steps. Step number 1, group your x's. Anything that has an x in it, group it together. Plus, and I'll tell you why in just a minute, just let it always be a plus. And then group your y's together. And then anything that doesn't have a variable, carry it over to the other side. Okay? Step 1, group your x's and y's and move everything else to the other side. Group your x's, group your y's, and move your constants to the other side. Step number 2, complete the square. But you have to remember the rules for completing the square from Math 100. In order to complete the square, your leading coefficient must be 1. You cannot complete the square unless your leading coefficient is 1. Okay? So for my x grouping, we're good, right? Your leading coefficient is 1. So this is going to turn into x squared plus 2x plus what? 1. Half of being squared. Half of 2 is 1. 1 squared is 1. Plus, we're going to pull a 2 out because my leading coefficient needs to be 1. So we're going to have y squared minus 10y, complete the square. Half of 10 is 5, and 5 squared is 25, is equal to negative 43. Now I have an unbalanced equation. Can you tell me what I need in order to balance it on the right-hand side? We're going to add 1, which would be 50. So we're going to add 50. That's fine. Alright, so now let's clean this up. Let's factor our squares that we just completed. So we're going to have x plus 1 quantity squared plus 2 times y minus 5 quantity squared is equal to whatever that method's going to be, 8. Are we there yet? What needs to be done? You got to divide everything by 8. Alright, so this is going to turn into x plus 1 quantity squared over 8 plus y minus 5 quantity squared over 4, all I did was reduce, is equal to 1. Are we there now? Yes, we are there now. What is the center? Be careful with this. Negative 1 and positive 5. Here's your h, and here's your k. And you're going to take the opposite of what you see because my formula tells me so. Now you should be taking this and running with it. You should be able to finish this out. I did the hard part for you. Which set of formulas are we going to be working off of? What is a squared? A squared is 8, b squared is 4, so a squared is bigger than b squared. So top or bottom? You're going to work off the top set of formulas. So, alright, let's discuss this. In order to know the vertices, I have to know what a is. A is going to be the square root of 8, which is 2.83. And b is going to be the square root of 4, which that's easy, that's 2. Alright, so to know the vertices, off of that top set of formulas, I'm going to do h plus or minus a. So negative 1 plus 2.83 is going to be 3. No, it's not. Hey. Okay.
On the formula sheet, it's like x minus h.
That means to take the opposite of what you actually have in your problem.
Okay. So you have negative 1.
Because we actually have a positive 1 in our problem. Anytime you see that minus sign in your formula, take the opposite of what you see. Okay? So vertices are going to be negative 1 plus 2.83, which is going to be 1.83, and leave k alone. And then the next one's going to be negative 1 minus 2.83, which is going to be negative 3.835. In order to know, let's see, the minor axis, this time the h is going to stay the same, and we're going to do the 5 and the b. So 5 plus 2 is going to be 7, and 5 minus 2 is going to be 3. So there's your minor axis. Now for the foci, we're going to have c squared is going to be a squared minus b squared. So c is going to be 2. Is that right? So the foci, going back to your formulas page, I need h plus or minus c. So negative 1 plus 2 is going to be 1, 5. And negative 1 minus 2 is going to be negative 3, 5. So there's the discussion. All right, let's graph. Center is going to be negative 1, 5. I told you we would be off the center, and we are. Vertices, we are totally going to guesstimate these. 1.83 being at 5. And negative 3.83 and at 5. Minor axis is going to be negative 1, 7. And negative 1, 3. So there you go. All right, so identify, discuss, and graph. Are we good? Okay. So let's go the other way. If I ask you to find the equation, now I want your equation to look like the one on your formulas page. Okay, I want your equation to look like either one of those on the formulas page. Look at what we know. We know that the vertices are 0 plus or minus 7, and we know that the foci are 0 plus or minus 2. So we don't know h and k yet, do we? We don't know what h and k are. But I know that this is b. Can anybody tell me why I know this is b? Which one changed? K. The second one changed. Your y coordinate changed. And remember I told you y, k, and b always go together. Y, k, and b always go together. So I know that that's going to be b. And then I know that this is c. Can you tell me why? Look at your formulas. Which set of formulas, looking at the vertices only, which set of formulas has the b that changes? Top or bottom? Bottom. So you automatically know that when we're going off the foci has c, of course, and you know that going off that bottom set, you have plus or minus c. Okay, so let's look at this. Let's use what we know. We know c and we know b. What formula on your formula page uses c and b together? The formula to find what? The formula to find the foci, right? The formula to find the foci is the only formula on your whole entire page that uses A and C. I'm sorry, B and C. We're working off the bottom set. We've already determined that. So let's write down that formula. C squared is equal to B squared minus A squared. Well, do you know what C squared is? What is C squared? I'm saying C is 2. What is C squared? 4. And it doesn't matter if C is positive 2 or negative 2, does it? Because when you square it, they're going to go away. Do what? The K did change the K changed by C. Okay. What is B squared? 49. And we don't know what A squared is, but we can figure it out. Right? So if we minus 49, that's going to give us a negative 45 is equal to negative A squared. And of course, we know we don't need the negative, so we're going to have A squared is equal to 45. So A is going to be, well, we don't really need to know, but A is going to be what? Some decimal. We don't really need it, but square root of 45. Like I said, we don't really need it. But. Okay, so now we know a squared, we know c squared, we know a, we know c, we know b, and we know b squared. Let's write down the formula and see if we have helped ourselves any at all. The formula that we're trying to get to is x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Have we helped ourselves any at all? Okay, let me ask you this. Go back to your vertices and your foci. We discussed how we knew that the plus or minus 7 was B and the plus or minus 2 was C. We discussed that, right? Because they changed. They're the ones that changed. So we know that that's B and C. But we didn't even look at the first one. Did the first coordinate change at all? No. So no matter what, X has to be what? Or H has to be what? H has to be 0. H has to be 0.
That doesn't get written down in the formula, right? You write it, huh? Which is Bx.
Yes. Yes. You're step ahead. Yes. So for the first part, yes, Frank, that does help us. This goes to 0. So we're going to have x squared over, what did we say a squared was? 45. Plus, what can you tell me about k? It's going to be 0 also. So you're going to have y squared over b squared, which we said was what, 49? Is equal to 1. And you've got it. Because the plus or minus 2 or the plus or minus 7. If it was different numbers, then k would have to be different. But since they're the same numbers, it has to be 0. So in other words, if k was 2, there's no way we could get a plus or minus 7 for b. Right? So because it's not plus 2 or minus. Because it's not two separate order pairs. Correct. Mm-hmm. Okay, so when it asks you to find an equation, first thing you need to do is use what's given in order to figure out which set of formulas you're working off of. Okay, and then find the missing ingredients, which is what we just did. Let's try one more. Let's look at this one. Now this one's a little different because I've given you different information. It says find the equation of ellipse with the foci of plus or minus 3, 0. That should be a big hint. And your minor axis length of 2. Your minor axis length of 2. And I gave you a little bit of a hint on your cheat sheet, but we'll get there in just a second. Let's work just off the foci, okay? Which one changed, H or K? H changed. So look at your formulas page and tell me which one am I working on, the top one or the bottom one? I'm working on the top one, okay? H changed in the foci, so I'm working on the top one. Now what I want you to do is I want you to look up there where it says endpoints of minor axis, and I want you to look out to the far right. Someone has written something there. What do you see? That's a 2B. 2B. So the length of the minor axis, 2B, is equal to 2. So B has to be equal to 1. That 2B and 2A and all that down through there, that tells you the length of your minor axis and the length of your major axis. We used that in 112, and I didn't erase it for y'all, so there you go. 2B is the length of your minor axis on the top set. Now, if you look at the bottom set, understand that the length of the minor axis is 2 times A. Okay? So I know that b is equal to 1, so b squared is going to be what? 1. So let's write down what's missing. What's the missing ingredient? A. I know C, right? I know C. I know B. So now I need A. I know that this is C because foci is the only one that uses that variable. Okay? So we said that we were on which set of formulas? The top. So we're going to have C squared is equal to A squared minus B squared. What is C squared? C squared is going to be 9. We're looking for A squared. B squared is just going to be 1. So A squared is going to be what? A squared is going to be 10. And I mean, you can take the square root of it, but you don't need it. Let's write our formula down. We're going to have x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. What can you tell me about h and k? They're 0. So you're going to have x squared over 10 plus y squared over 1 is equal to 1. And there you have it. Okay? Figure out what you need. What's the missing ingredient? Figure it out. Write your equation.
Which one do we use the top?
We use the top. Because in the foci, that's what changed. In the foci, since your h changed, you use the formula, the top set of formulas. Got it? Sure.
Yeah.
On the diagram, on the handout here,
Mm-hmm.
I don't quite understand all the little symbols. They got A, a C, and a B. Is that C there, is that like a center, or is that a C square, or?
Let's see, that's your foci. Notice where you're in construction, so when you look at a blueprint, you know that when you do this, that's a distance.
Right.
So that C is going from the center, to this dot, and this is your foci because your vertex is way out here. So from here to here is C. And then if you'll notice on the other side, it's going from here to here, which is your A. Your C tells you the distance from your center to your foci, and your A tells you the distance from your center to your vertex. And then when it says B, the distance from here to here is B. The distance from your center to your minor axis, your endpoint of your minor axis, that's B.
Okay.
Anything else? Let's talk about hyperbolas. Okay. So let's go back to the formulas page right quick. Now, look at this formula that's on the board and compare it to the ones that we just came through. They look almost identical, do they not? What's the main difference that you see? Subtraction sign. This tells me that I'm looking at a hyperbola. If you see that subtraction sign in your fraction, once you get it set up in what we call standard form, then you know you're looking at a hyperbola. Okay? Minus sign means hyperbola. Plus sign means an ellipse. One squared term is a parabola. Those are the three things that you need to know in order to identify. Okay. Now, hyperbolas are a little more difficult than ellipse simply because addition, which is in our ellipse, both terms are positive, it's commutative. So it doesn't matter how we write it. Typically we write x first, but it doesn't really matter because addition is commutative. However, subtraction fraction is not commutative, and this is huge, okay? This is how you are going to know which set of formulas to use on your formulas page. Look at your formulas page and look and compare the problem on the board. Which squared variable comes first? Y. Look at your formula page. Find the formula that the y squared term comes first. Top or bottom? Bottom. So that's how you know which set of formulas to use. Okay? Alright, so I know that I'm working on the bottom set of formulas. I've already identified this as a hyperbola because of the minus sign. So let's just go ahead and start discussing this. For my center, what do you know? It is 0, 0. Now, for the vertices, what variable do I need to know? B. Look at your formulas page. I need to know what B is. I know what H and K are, right? H and K are 0. I need to know what B is. Now, let me give you a word of caution, and you've heard me say this 3 times already. Let's see if you were paying attention. Tell me what B is. Very good. Very good. This is B squared. So B is going to be 7. Remember I told you, Y, K, and B all go together. Always. You cannot separate them. Y, K, and B always go together. X, H, and A always go together. So can you tell me what A squared is, or what A is? A is going to be 4. Alright, so now you're ready to discuss completely. We're on the second set of formulas. So your vertex is going to be 0 because your H doesn't change. And then K plus or minus B, which in our case is going to be 0 plus or minus 7. And we can lump it into one set, really. Even though we know that this is 2 different points, yes? Okay. Keep going. Now this is going to be called the conjugate axis rather than the minor axis. This is going to be the conjugate axis. Conjugate axis is going to be H plus or minus A, which is going to be 0 plus or minus 4. And then K does not change, so we're going to get 0. Now, the nice thing about these is the fact that the foci formula to find C squared or C, it doesn't change. Okay, it's the same for both of them. So, in order to find the foci, we need to know what C is. So you have A squared plus B squared is equal to C squared. And that should look very familiar to you. So we have 16 plus 49 is equal to C squared. So C is going to be 3.46. Is that what you got? No, I'm looking at the wrong one. Sorry. Yeah, I'm looking at the wrong. It's 8.06. Is that what you got? There we go. I was looking at the wrong problem. Alright, so C is equal to 8.06. So now we can do the foci. The foci, working off the bottom one, is going to be H stays the same. And then 0 plus or minus C, so we're going to do plus or minus 8.06. Now, down the bottom where you see asymptotes, you can cross those off because that's 112 stuff. We're not going to do the asymptotes. Okay, so we identified, we discussed, now let's graph. Our center is going to be 0, 0. Now, in order to draw a hyperbola, basically what a hyperbola is 2 parabolas going away from each other. That's what a hyperbola is. And we talked extensively about it in 112 for those of you who came through pre-cal. But I want you to watch me graph this, okay? Because it's really, really easy. Just pay attention to what I'm doing. I know that I'm on the second set of formulas, so I know that it should, my hyperbolas should be going up and down. Okay? So, for my vertices, I'm going to get 0, plus 7, and 0, negative 7. These are the vertices, and you may want to label them because that's what your parabolas are actually going to sit on. Remember, your parabola sits on your vertex. Alright, conjugate axis is going to be plus 4 and minus 4. And so what you're going to do is you're just going to draw a box like this. Now, as far as the asymptotes are concerned, your asymptotes are the diagonal lines that go from corner through the center and to the corner. So there's one asymptote, and here's your other asymptote. The asymptotes just tell you how wide your parabola or your hyperbola is going to be. So the hyperbola is actually going to look like this. Remember, an asymptote is a line that the graph can get really, really close to, but it'll never touch. And so those asymptotes are just basically guidelines. And so the green is what I'm looking for. The green is what I'm looking for. Questions? Okay, let's look at the next one. Can you identify this, and can you tell me why? How do you know it's not a parabola? Because you have two squared terms. How do you know it's not an ellipse? There's a subtraction sign, in particular, in between the two squared terms. There's a subtraction sign in between the two squared terms. Okay, so this is a hyperbola. But it's not in standard form. What am I going to do to get it in standard form? We're going to divide by 8. Alright, so we're going to have x squared over 8 minus, and I'm going to reduce here, y squared over 4, just reducing, is equal to 1. Now, we got to figure out which set of formulas we need. Which squared variable comes first? Your x. I guess I should say this. Which squared variable is positive? Because that's the one that should come first. Okay? So since it's your x ones, we're going to go off the top set of formulas. So your center is going to be hk. What is that going to be? What's the big hint there? How do I know it's 0, 0? No parentheses. Alright, let's go off the vertices. In order to find the vertices, I need to know what A is. Can you tell me what A is? Yeah, it's the square root of 8. So it's going to be 2.83. So your vertices are going to be plus or minus 2.83, because it's 0 plus or minus 2.83, and 0. Your conjugate axis, what variable do I need to know? B, and can you tell me what B is? Good. So we're going to have 0 plus or minus 2. Now in order to find the foci, again, we need to use our formula. So we have c squared is equal to a squared plus b squared. So c squared is going to be 8 plus 4. So c is going to be the square root of 12, which is 3.46. That's where that number was coming from a while ago. So I know that my foci is going to be plus or minus 3.460. So there's the discussion. Now let's graph. So the center is going to be 0, 0. Vertices are going to be plus or minus 2.83. So we're going to guess on these. And then the conjugate axis we're going to go up 2 and down 2. From here we can draw our box. And we can draw our asymptotes. Now, question. Is this hyperbola going up and down or left or right? It's going to go left and right because we use the first set of formulas, right? So it's very important that you understand which of these 4 dots are your vertices. Very important to know which of these 4 dots is your vertices. And so what am I looking for? I'm looking for this right here. I'm looking for the green. Questions? Okay. If I gave this to you on a test, could you tell me which one it was? You know it's not a parabola, because you see two square terms, and in between the two square terms, what do you see? Minus sign. And hopefully that's a hint as to the fact that it is a hyperbola. But let's put it in standard form and find out. Okay, let's put it in standard form and make sure. Do you remember a while ago when we were doing an ellipse like this? What was the first step? Group them. Yes. Group your x's, group your y's. So we're going to have and what did I tell you to put in between your groups? Always. Always put a plus sign in between your two groups. So for the y, and then everything else is going to go to the other side, right? So we have a negative 10. Okay. In order to complete the square, what did I tell you how you had to have? Your leading coefficient has to be 1. So out of that first group, what do I need to factor out? A 25. And half of 4 is 2, and 2 squared is 4. But now, out of the second group, what do I need to factor out? A negative 9. Now do you see where the negative comes in? That's where that negative is going to come into play. So now I know for sure, 100%, that this is going to be a hyperbola. Make sure you pay attention to your signs, okay? All right. I have an unbalanced equation. Can you tell me what I need to put on the right-hand side in order to balance it up? $100, a positive 100, and what else? A negative 81. Very good. Very, very good. All right, so let's clean it up. Let's factor the completed squares. So we're going to have x plus 2 quantity squared minus 9 times y plus 3 quantity squared is equal to, when you combine all those together, what'd y'all get, 9? This is ridiculous, but we're going to do it. I don't think y'all have ever done a problem like this before. And I know we didn't do one in 112 like this. But in Cal 2, I think we can handle it. Okay? In order to get this in standard form, what do I need to do? Divide everything by 9. So that first one is going to be extremely ugly. But that's okay. What are we going to get? We're going to have x plus 2 quantity squared. Now I need that 25 to completely and totally go away. Completely and totally go away. How do I do it? Alright, so minus, and then this one, it just goes away completely. But make sure you have a 1 there, because you got to have a b is equal to 1. Does everybody understand why that went to 9 over 25? If I multiply the top by 1 over 25, that gives me 1 on top, which is what I need. But if I do that on the top, I have to do it on the bottom. Okay? Now, the fun part. Can you tell me what A is? 3/5. Very good. Have you figured out which set of formulas we're going to use yet? Top or bottom? Top. Why? Because your X grouping comes first and it is positive. So we are going to use the top. So I know what A is. I know what B is. We'll find C in just a minute. Let's go ahead and start discussing this, okay? So C is going to be what? -2, -3. Good job. V, your vertices. This time we're going to combine H and A. So I'm coming up with -1.4, and then of course the -3 stays as is, and -2.6, and the -3 stays as is. Next thing I need is the conjugate axis. So for the conjugate axis, I'm going to do H, which is -2, and I'm going to do K plus or minus B. So that's going to be -3 plus or minus 1, which is going to give me a -2 and a -4. All right, let's find the foci. We need C. So A squared is going to be 9 over 25. B squared is going to be 1, and that's going to be C squared. So put it in your calculator. Tell me what you get. What did you say, Frank? Yeah. Let's go with 1 point. Let's just round it. What, 1.2 you think? Just to make it easy. How about that? All right. So to do the foci, we are working off the top set. So -2 plus 1.2 is going to be what? -0.8. Is that what you got? Yes, no, maybe. And then -3.2. -3. All right, so there's the discussion. Let's graph it and see if it all comes out. Which way, let's go ahead and get this in our brain. Which way are these, which way is the hyperbola going, up and down or left and right? Left and right, very good. Make sure you keep that straight in your brain. So we have -2, -3. Your vertices are going to be -1.4, -3. And this is going to be tiny. -2.6. Conjugate axis is going to be -2, -2, and -2, -4. Oh my goodness gracious, are you kidding me? Very ridiculous. But it is what it is, huh? And we're going left and right. So again, the green is what I'm looking for. right, the last problem of your Cal 2 career. Dun, 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 is bonus points. You can turn it in tonight. You can turn it in with your test on Wednesday. Whatever you want to do. It's completely and totally up to you.